I'm Deepa. I am here to explain about my assignment for ATC, and my project topic is MiniATC language, which is used as a lexical analyzer and parser. And I have selected out of 3 levels, I have selected a level 3. And in this project, I have implemented a lexical analyzer and parser for MiniATC language using Python and Flask. And the system accepts the user defined inputs and generate the tokens, validates syntax using CFG. CFG means context-free grammar, and displays the step-by-step output for valid and invalid programs. Okay, let me share my screen and go through the deep. Okay. See. Okay, this is our problem statement, and the objectives of this assignment is to design and implement a lexical analyzer and a parser for the MiniATC language. Okay, the lexical analyzer converts the source code into the tokens such as keywords, identifier, numbers, and operators and delimiters. Okay, the parser then verify the context-free grammar as CFG of the MiniATC. Okay, like this. These are some keywords, identifiers, numbers, operators, which comes under CFG. Okay, these are the delimiters, and then moving towards implementation also provides the step-by-step output and error reporting to the better understanding. Okay, then come to this mini language specification. See, as we can look of the page number 3 like this. Okay, then we can see the pages show MiniATC languages specifier, like used as a specifier. Identifier must start with a letter and can contain letters and digits, and numbers are non-negative integers. Like by using all the CFG, we have taken one example of that, and here we can see all that operators and identifiers, delimiters, like that here in this simple example program. Okay, then also and this delimiters is also sample MiniATC programs. Okay, then move on to the token design. We can also see here in page number 4. Let me see. Okay, see, these are the tokens generated by generated using DFA-based scanning. Okay, see, then the token type contains the keyword, identifier, number, operators, delimiters, and UOF, means end of the inputs. Okay, then keywords like begin, end, and int, print, exact match. Okay, if we want to start some program here, we have to begin that first. If we didn't use the begin keyword there, then it shows error in the program, like that. Okay, then identifier, if we are addressing some letters or digit, we have to represent that, right? So we have to represent in X, some, or any other letters or digits. And numbers, we have to represent some numbers like in the digits. We have to represent like that only. So, and the operators, if this character we need to concatenate, or we need something to be there in that single character, or if we have to add something, we have to make a power to that, like that we have to use that operators. Delimiters is which we have to use in this program, because without semicolons we did not get the valid output here. EFO means this is the end of the program. We used a keyword as end. That's all. And next, then we have to move for and in that token design, we can also say that each token as it lexical role and lexema examples. Okay, we have already go through that simple example. We can easily understand that. Okay, then let's move on to the DFA for identifier and keywords, which is very important in this. Okay, DFA is used for recognizing the identifier and keywords. As I already said, this is the DFA used to recognize the identifier and keywords. Okay, then here we have a 3 state. Q0 is a start state, Q1 is a accepting stage and also final stage. Also Q error is a dead state. And here we have used alphabet A to Z, uppercase and lowercase, also digits from 0 to 9 and others. We have a transition state here. Based on that, we have to and transition tables. See, each transitions. Okay, if the first character is a letter, DFA transition from Q0 to Q. As we can see here, transition function or in a transition state, transition table, we can see that Q0 has going to the next state to Q1 when when letters will come. Okay, means Q0 is accepting the only letters and moving towards next state, which is final state. If we get the digits first or any other others, it will show error, means it will go for a dead state, it will not accept here. Okay, and Q1 is already if the letter is there, it will repeat there. If the digit will get, it will accept that, but if any other will come there, it will not accept. That explained in this diagram. See, Q0 is going towards the Q1, which is next state and a final state. It is accepting the letters, and when the digits or other things came first, it will go for dead state, and when the letters or digit come next to the letters, it will accepting in the final state. Okay, in simple way, we can say that if the first character is a letter, then DFA transition from Q0 to Q1 also, and accepting state, Q1 is accepting the state right here, and once the automata reaches to Q1, additional letters and digits are allowed repeatedly using self loop. Okay, this is the self loop. Okay, if the identifier start with a digit or invalid symbols, DFA transition to the dead state. Like already we said, if it is not identifier, right? It is not a keyword, so it will go for the dead state directly. Coming towards which is DFA for numbers. Okay, here we same 3 states are there. 3 states we have alphabet 0 to 1, because it is a number, so we have alphabet 0 to 9 and others. And here we also see that if the digit come first, it will accept in Q2 state. If the next number is also digit, it will accept. If any other, it will go directly to the dead state. If digit after the digit, if any letters or other characters appears, it will also move on to the dead state. Okay, in simple way, we can say that additional digit are allowed repeatedly using self loop on Q2 when it is only a digit. Okay, if any non-digit symbols are transition in, will be go to dead state Q error. Okay, example we can take that 1 2 3 4. Okay, it will accept if 1 A B C, it is not accept. One will accept and other will not. That's it. Next, CFG and Parser Logic. These are some predefined definitions and CFG programs using MiniATC, and for a MiniATC also. These are the some syntaxes, and the main grammar rule is program begin with begin letter and end when it is middle of that, it's a statement list. Okay, in that statement we can include the declaration statement, assignment statement, print statement. And the explain expression means this supposed to say that arithmetic operations and preceding handling. And parser approach, parser approach means it is like this. Okay, this parser approach using recursively descent parsing, which is top-down parsing techniques, and each non-terminal is in a CFG is implemented as a separate function. Okay, then explain utilization means peak, weave current token, move forward, and validate expected tokens. Parser stops immediately on the error and report exit line like that. Then we will move to the implementing part. Let's see that. Okay, this is our code based on the Python and Flask. Here we have to mainly focus on something 3 to 4 points. Let's see. Okay, tokenize means it is a tokenized function, scans the source code character by character and converts it into the tokens. Parser classes parser classes next parser classes, here we have to validate whether the token sequence follows the grammar rules or not. Okay, then we have in this see, this is the token parser, and this is the expect, means this checks the whether current token is matches to the expected token type. Then parser expect, here this we can say this function handles the arithmetic expression and operator precedence. This is how we have designed our program by using the Python and Flask. This is our output. This is the valid program. Okay, when we run this program, it will tokens like this and Lexer steps like this, which is in the CFG type, and parser steps is like that, and result is valid. Then see, Lexer is generating the token successful, and parser validates the syntax step by step. Finally, the result, the system displays the valid program here. Okay, then we try for any invalid programs like this. We remove that semicolons. See, it is showing like line 4 expected semicolon got print. See, parser expects the semicolon after identifier, but semicolon is missing. The parser generates the syntax error like this. Okay, as I said, it is also expected some user inputs. So see, this is our let us take any other numbers. If we run this, it will show valid program. If in the case we will blank that so that we can take this as a invalid. Okay. Then we will go through some more test cases. Okay, see, here are some test cases. Test cases. Begin and end should be must and should, and single declarations. These are some valid test cases. Missing semicolon is invalid, and missing assignment under equals to and greater than or equals to and any other operators, which is assignment operator, right? So that if it is missing, it is also invalid. If any unknown symbols like dollars and ash like that symbols, it is shows like invalid. And empty string, if we add anything like we have test this one, right? In this user invalid statement, we just blank that, so it shows like invalid. And missing begins, if we miss the keyword begin, it will get invalid statement, as I said before. That's it. And coming into the conclusion part, this project successfully demonstrates the DFA-based lexical analyzer and token classification and recursive descent parser using CFG and syntax validation, and the error detection with the line numbers and step-by-step execution also. And finally, this project demonstrates how automata theory concepts are partially and practically applied in the compiler design and syntax analysis. This is our project. Thank you for your precious time. Thank you so much.